The question says that a solution of tripotassium phosphate is mixed with zinc nitrate. So first things first, this is a lot simpler than oxidation reduction, right? So all we're going to do is make sure the charge is unbalanced, and then we're going to check for solubility. First things first, tripotassium phosphate. So I'm just going to write K3PO4, right? Tripotassium phosphate, because PO4 has 3 minus charge, we need 3 to potassium to balance out the charge. And you have zinc nitrate. Zinc has positive 2 charge, nitrate has negative 1 charge. So you're going to have to write NO3 with the 2 in the middle. Now, all of that this has to do with is which one's going to be there, right? Okay, so let's check for solubility. K3PO4 falls into group 1 ion.
They're both soluble.
Right, they're both soluble, right? So most salts containing group 1 ion and other ammonium ions are soluble. Well, this is group 1, so we're going to say that this falls apart. So I'm going to write 3K plus and PO4 minus 3. Okay, most sulfate salts, that's not one applicable. Let's see, which one has to do with the nitrate and zinc?
It says...
Number 1, most nitrate salts are soluble. So no matter what nitrate is bonded to, it's going to be soluble. So it's going to fall apart. So zinc plus 2 and nitrate 2 NO3 minus. Now, all you're scoping out is opposite charges attract. So K and PO4 were together, but they fell apart. So that means this 3 positive ions of potassium is going to bond with this 2 negative ions of nitrate, right? So I'm just going to do a swapping. So you have K2NO. Right, it doesn't really matter, but I'll tell you why it doesn't matter, right? I just swapped it. So I wrote this wrong because potassium has positive 1 charge and nitrate has what? 1 charge. So if you write it out, it's going to be potassium nitrate. Zinc, it's going to be ZN3PO4 with the 2. Because remember, charges crisscross, correct? Alright, here's the thing. What do we know about nitrate?
It's soluble.
It's soluble. That means it's going to fall apart. So if I rewrite this, it's going to look something like this. Now, tell me.
Spectator ions.
Tell me which ones are my spectator ions.
KNO3.
Okay, so the fact that potassium and nitrate, when they bonded together on this right, hey, be quiet in the back. Yeah. Potassium and nitrate, when they bond together, it's going to be soluble. Potassium phosphate was also soluble. So what ends up happening is nitrates cancel out, potassium cancel out. So your net ionic equation is PO4 zinc 2 plus. But is zinc 3PO4 soluble or insoluble?
Insoluble.
It's insoluble, so that's going to stay together. So your net ionic equation for this is just going to be PO4 3 minus with zinc 2 plus yields zinc 3 PO4 2. Now, 2. Really, really important thing here is that even you understand the whole net ionic equation and sign swapping, so the positive bonding with the negative, if you don't know how to write a formula with the right coefficient because you didn't learn the charges, you're not going to get anywhere. So this is a time where you have to go back to your polyatomic ion sheets and memorize it. Okay?
Yes.